at this stage of the course, you're always going to get two pieces of information. You're going to get an equation to actually solve, hence solve trigonometric equations, and then you're going to get a domain, okay? We'll come back to that in a second. You'll notice that I put up a red flag here. Wave my little red flag. I should actually get a red flag. That would be really good. And I would literally pick it up and wave it. Because, as I've mentioned before, there are some kinds of questions and some particular skills that come up again and again and again, and they form a critical part of other things you need to solve. Okay? So, solving trig equations is one of them. You will be solving these for a long time, and they often form a really critical part of some other problem, right? So you really want to master these. These are the kinds of things you want to be able to do without thinking, really. All right? Now, I said you're going to get your equation, and then you'll get your domain. Okay? Why is it that you need a domain supplied with the question? Any takers? Any question? Yeah.
Because cos has two quadrants as positive.
Okay, so the first thing is, look, these things are going to have more than one solution, right? So which one, okay? That's the first point. But secondly, there's something even more than that. It's got more than two solutions, right? Yeah, Raf.
It's got an infinite number of solutions.
Good. Any trig equation, right? If it's equal to some number, assuming there is a solution, if you don't supply a domain, you're just going to get solutions forever. Because have a look. This is what cosine looks like, right? And this is posing the question, when is cos x equal to a half? And that happens rather a lot of times. There's one, so a half would be about there. And here are all my solutions. Okay, so you have to be watchful for this. There will come a time when we'll say, no, you know what? You can give me a solution for this, and you can write it in such a way that it captures all of the solutions that are there. And that's its whole own topic. It's called general solution because it means there's a solution that's generally always true. Look, there's clearly patterns here, right, that can be taken advantage of. But for now, we're just looking at it in a specific domain. Okay, so this is kind of your standard domain. It's not the, not every time you're going to get this, so you do have to read it carefully. Another common one is between minus 180 and 180, but this is what we've got at the moment. That's where cos x stops from 0 to 360. Okay, so I've put it up there because I think that's your most helpful way to solve this. Let's give this a go. You got cos x equals a half. Now, a half I've provided because it's an exact value, right? What's the exact value of x in degrees that would give you a half? What's your acute angle? It's going to be 60 degrees, right? 60 degrees. So I'll just put this on the side here. 60 degrees is what we call, and you've heard these phrases before, our base angle or our related angle, okay? If you put cos 60 into your calculator, you would get a half. And likewise, if you put cos inverse of a half into your calculator, you get 60 degrees, assuming you're in degrees, okay? But there's another solution, right? So, have a look at the symmetry here. You can see I'm going forward 60 degrees, and that gives me the first solution. Looking at the symmetry of this thing, how do I get, not just what's the angle, how do I get the other angle? What do I do? Yeah, Nikita.
360 minus.
Good. This is 0, and this is 360 right at the end, right? 360. So being that they're going the same distance from either side, I'm going to have to subtract 60 degrees, which of course gives us our solution, 300 degrees. Okay, so I'm going to say 60 degrees or 300. That's it. That's all there is to it. Okay. Alternatively, if you didn't want to think in terms of the graph, you would think in terms of this. You would say, okay, look, I've got cos and it's positive, so which two quadrants am I interested in? Quadrant 1 and quadrant 4, right? Tick, tick. Okay, so you'd say, all right, I've already got my 60 degrees in here. In order to go to quadrant 4, I'm going to go all the way around until I get 60 degrees there, and that's 300 degrees, right? Same answers, it's the same thing. It's just this is looking around the unit circle, okay? There's my two solutions. That's it.